So we're now going to continue on with our discussions of the newer features that have been added to Java to be able to take advantage of virtual threads. And we're going to start by talking about Java's TaskPerThreadExecutor, which is a variant, somewhat of a lobotomized variant, perhaps, of Java's structured concurrency model. So this feature adds two new factory methods into the Java Executors utility class. And it also extends the executor service interface just a touch. And we're going to talk about how it's been added, it's been extended to add support for this auto-closable interface that is now extended or inherited into the executor service. The two new factory methods are newVirtualThreadPerTaskExecutor and new work stealing pool. Actually, I take it back. It's just the newVirtualThreadPerTaskExecutor. And that's what's known as a preview feature. This new ThreadPerTaskExecutor factory method starts a new thread for each task. And the type of the thread can be designated by a thread factory that's passed as a parameter. So you can either have threads that are going to be regular good old Java threads, or they're going to be virtual threads. You can control that. Then there's also another method called newVirtualThreadPerTaskExecutor that starts a new virtual thread for each task. So you don't have a choice. You get a virtual thread here. This is also this preview feature that was added here. So let's take a look and see how this can be used. These executors, like other executors in Java, can now be used with Java's Try with Resources feature, which is an interesting feature historically designed primarily for exception handling, but now has also been extended to take advantage of the ability to close things down and shut things down at the end of a block or end of a scope. So you can see here, for example, here's a simple little example where we make ourselves a new executor that's a virtual thread per task executor, and it's going to be live or in place from the opening curly brace to the closed curly brace that I've highlighted in red. Now, this particular example is going to be kind of interesting. It's going to really stress things quite a bit. It's going to generate 10,000 values from 0 to not 10,000, 10 million values from 0 up to 10 million minus 1. And for each of those values, then it's going to create a new task by submitting it. That's how you create a new task in the Java Executor framework. Except because this is a virtual thread per task executor, it's actually going to create a virtual thread for each of those tasks. So to quote Dr. Evil, I'm going to start 10 million virtual threads. And so that's an awful lot of virtual threads. All of these virtual threads, which in this case are going to do something mindless, they're just going to sleep for 1 second. They all have to be completed by the end of the enclosing scope. So this is basically providing a kind of a co-begin, co-end like barrier synchronizer structure that will have all these computations all running and sleeping for a second. And that's a lot of threads. Again, 10 million threads is a lot. Now, works very nicely, very simple. However, it's also somewhat limited, which is why it doesn't get anywhere near as much of attention as the other Java structured concurrency features like the structured task scope that we talked about earlier. In particular, it lacks support for fine-grained exception handling. So you can't really handle exceptions in a fine-grained way. It also doesn't support invoke any semantics. It's going to run everything, not just the first thing that is going to complete. And you also don't have support for automatic task cancellation. They all basically run to completion within this scope block. However, there are places where it's handy to have this capability. And in particular, we'll get this a little bit later when we start talking about how things work in Spring. With Java Spring Web MVC, you can actually define a bean, which is basically a way to customize the behavior of the system, that will create a new Java virtual thread to process each incoming client request. And the way you do it is through the mechanism shown here, where you make a new task executor adapter that's connected to the new virtual thread per task executor from the executors framework. So you can basically just kind of drop this thing in, and then every time a request comes in, rather than being processed by a thread in a pool of threads. Instead, it's going to be processed by a new virtual thread per request. And we'll get around to playing around with this in some of the assignments and some of the examples we're going to take a look at in just a bit. Because the executors feature that creates a new virtual thread per task is limited, that's what motivates the new Java structured task scope, which is what we're really going to be focusing on and what you'll get a chance to do in upcoming assignments. So here's just a simple example that we'll look at where you're going to do two operations in parallel. You're going to find a user and fetch an order. And if everything works as planned, you're going to wait for those computations to be done. And then you're going to grab the results from each and return a new response object. And if something goes wrong, then we can throw an exception that indicates what went wrong. So that's the end of a quick overview of how to program with Java ThreadPerTaskExecutor. Again, not the most commonly used structured concurrency model in Java anymore, but it is useful to know how it works, especially if you're dealing with customizing Spring Web MVC to handle a thread per request model using Java Virtual Thread.